10 days. That is all the time that remains before one of the most extraordinary cosmic visitors ever detected makes its final appearance in our celestial neighborhood. On March 16, 2026, the interstellar object, known as 3I Atlas, will perform its last high-speed passage through the Jovian system before disappearing into the vast darkness beyond our reach. For scientists, this moment represents far more than a passing comet. It marks the closing of a rare cosmic window, a brief instant when a traveler from another star system drifts through our own and offers humanity a glimpse into a chapter of the universe written long before the Sun or Earth even existed. Through the lens of modern physics, we are not simply watching a rock drifting through empty space. Instead, researchers are carefully studying an object that carries the chemical fingerprints of a time before our solar system formed. The materials inside its crystalline structure may have remained untouched for billions of years, preserved since an era when our planet had not yet taken shape. That possibility alone makes this encounter one of the most important scientific opportunities of our generation. The story of 3I Atlas began publicly on July 1, 2025, when astronomers first confirmed its discovery. But what has unfolded since then reveals something far more complex than a routine comet observation. As the object now approaches Jupiter, scientists are witnessing a convergence of orbital mechanics and observational opportunities that rarely occurs in astronomical history. On March 16, the object will pass within approximately 53 million kilometers of Jupiter. While that may sound distant, in astronomical terms, it places the traveler well within the gravitational influence of the largest planet in our solar system. Jupiter's immense mass bends the fabric of space-time around it with extraordinary strength. In fact, the planet's gravitational pull is about 318 times stronger than Earth's. Whenever an object approaches this giant world, its path is altered in a dramatic way. In orbital mechanics, this phenomenon is known as a gravitational assist or hyperbolic deflection, where a passing body gains speed or changes direction after interacting with the planet's gravity. Normally, such events occur unnoticed with small comets or asteroids, but this situation is different. Orbiting Jupiter right now is a spacecraft that has spent years studying the planet's magnetic environment. Juno. Since its arrival in 2016, Juno has been mapping Jupiter's magnetosphere and observing its powerful auroras. The presence of this spacecraft raises an intriguing possibility. At the exact moment an interstellar traveler crosses Jupiter's region of space, a human-made observer may be close enough to gather valuable data. Theoretical frameworks such as string theory suggest that the universe behaves like a system of resonating vibrations. When events align in certain ways, they create moments of scientific opportunity that feel almost orchestrated. Here we may be witnessing exactly that kind of convergence. A study involving Harvard astrophysicist Avi Loeb examined whether Juno could potentially observe or intercept the passage of 3I Atlas using its remaining fuel and instruments. Official announcements have not confirmed any attempt to redirect the spacecraft. Redirecting a probe with limited fuel is risky, and mission planners must protect the spacecraft's long-term objectives. Yet the reality remains striking. An object born around another star system is about to pass through the observational range of technology built by human hands. At the same time, another spacecraft has already collected a wealth of information about this mysterious visitor. In November 2025, the European Space Agency's JUICE mission briefly captured more than 100 high-resolution images of the object. Alongside the imaging systems, 5 advanced instruments, including spectrometers, ultraviolet detectors, and particle sensors, analyze the material streaming from its surface. However, the full story of those observations has remained hidden for months. After the spacecraft gathered its measurements, the data transmission path to Earth was blocked by the Sun itself. For nearly 3 months, the signals remained shielded behind the solar disk, unable to reach our receiving antennas. Only in late February 2026 did the information finally begin arriving at deep space tracking stations on Earth. Scientists are now processing that data, preparing detailed reports on the chemical composition of the object. Interestingly, the timeline suggests that the full scientific publication may arrive near the end of March. Just as 3I Atlas completes its passage past Jupiter and begins accelerating away from the Sun forever. To appreciate the urgency of this moment, we must consider the object's speed. 3I Atlas is traveling at approximately 58 kilometers per second relative to the Sunday. That velocity is far beyond what any typical comet from our solar system would possess. Even as it gradually slows while climbing out of the sun's gravitational well, it will still maintain an enormous excess velocity that guarantees it will never return. In simple terms, this visitor was never meant to stay. It arrived from deep interstellar space, and after a brief encounter with our solar system, it will vanish back into the darkness between the stars. And yet, before that departure happens, something remarkable will occur. As 3I Atlas passes near Jupiter, it will encounter the planet's magnetosphere, a vast and chaotic region filled with radiation and charged particles. When this happens, the chemistry of an alien star system will briefly mix with the energetic environment surrounding the largest planet we know. That moment may provide scientists with the most revealing data yet about the nature of this mysterious traveler. But the deeper we investigate the evidence already collected, the more puzzling the story becomes. Because recent research suggests that 3I Atlas may not simply be drifting through space. Some of its movements appear to challenge the very models scientists use to predict how interstellar objects behave, and what researchers have discovered next could change how we interpret this visitor entirely. Part 2 will continue directly from this point. Part 2 is approximately equal to 800 words. And what researchers have discovered next could change how we interpret this visitor entirely. A newly released forensic analysis has delivered one of the most detailed examinations ever performed on the motion of 3I Atlas, focusing specifically on something scientists call non-gravitational acceleration. In simple terms, this refers to forces acting on an object that cannot be explained by gravity alone. For decades, astronomers have understood that comets sometimes experience slight pushes when gas erupts from their surfaces. These outbursts act like tiny thrusters, gently altering the comet's trajectory as it travels through space. But what researchers are now observing with 3I Atlas appears far more unusual. The new data differs noticeably from earlier calculations published in the Jet Propulsion Laboratory's Small Body Database. Those official estimates suggested that the object's acceleration was primarily radial, meaning it was being pushed directly away from the sun by jets of evaporating gas. That type of motion is common among active comets. However, the latest high-precision analysis reveals something unexpected. Instead of a strong push directly outward, the object appears to be receiving almost equal acceleration sideways along its direction of travel. In orbital mechanics, this is extremely difficult to explain using normal comet behavior. A natural comet can certainly change speed if gas erupts from its surface, but producing a consistent sideways force requires a very specific arrangement of jets and rotation. Without such symmetry, the object would wobble unpredictably rather than maintain a controlled directional shift. To understand where this sideways force might originate, astronomers turn to the most detailed imagery available. Observations from the Hubble Space Telescope provided a series of high-resolution photographs taken during the period when 3I Atlas was most active. At first glance, the images appeared to show the typical bright halo surrounding a comet's nucleus. But when researchers digitally removed that glow and examined the internal structure of the plume, a fascinating pattern emerged. 3 narrow jets were visible erupting from the object's surface. These jets were not randomly scattered across the nucleus. Instead, they were arranged with striking geometric precision. Each jet was separated from the others by almost exactly 120 degrees, forming a symmetrical triangular pattern around the rotating body. This symmetry immediately caught the attention of planetary scientists. When an object spins while releasing gas from evenly spaced vents, the resulting forces can combine in very specific ways. In this case, the 3 jets appear to be modulating a rotational cycle of roughly 7.1 hours. As the nucleus spins, the jets repeatedly sweep through space like rotating thrusters. What makes this configuration particularly interesting is the orientation of the spin axis. Measurements suggest that the axis points within about 20 degrees of the direction facing the Sunday. That alignment means the jets are constantly exposed to solar heating, maintaining a stable pattern of outgassing as the object rotates. The result is a steady combination of forces pushing not only away from the sun, but also slightly sideways along the comet's path. In pure physical terms, The force involved is extremely small, about 1 micrometer per second squared. That number may sound insignificant, but in the frictionless vacuum of space, even a tiny continuous push can gradually shift a trajectory over time. In fact, calculations show that such a force could move the predicted position of 3I Atlas by roughly half the radius of the Moon within just a single month. For spacecraft navigation and orbital modeling, that level of deviation is substantial. It means that a body originally predicted to pass one location might instead appear thousands of kilometers away from that path. Yet what continues to puzzle researchers is not simply the existence of the jets, but the remarkable precision of their arrangement. Nature often produces chaotic structures, fractured surfaces, uneven vents, or random bursts of gas. But here the jets appear evenly spaced in a configuration that almost resembles an engineered pattern. Of course, most scientists interpret this symmetry as a coincidence produced by natural geological processes. Over billions of years, impacts and internal stresses could have created fractures that happen to align in this way. Still, the geometry forces researchers to examine every possibility. Some theoretical discussions have even explored whether the jet system could function as a natural navigation mechanism. If gas erupts from specific locations, while the object rotates, the combined forces could gently adjust its direction of motion, almost like a primitive steering system powered entirely by sublimating ice. The idea becomes even more intriguing when viewed through the lens of modern theoretical physics. Some researchers argue that interstellar objects might occasionally display behaviors we do not yet fully understand because they formed in environments very different from our own solar system. The chemistry of 3I Atlas already suggests it originated in a stellar region with unusual elemental abundances. Its structure may therefore follow physical patterns unfamiliar to us. Whatever the explanation, the evidence indicates that 3I Atlas is not moving through space as a simple inert rock. Its trajectory is being subtly influenced by processes occurring on its surface, and as those forces continue acting over time, the object's path gradually diverges from what pure gravitational calculations would predict. This realization brings us back to the approaching date that has captured the attention of astronomers worldwide. March 16, 2026 is rapidly approaching, and with it comes the final major gravitational interaction between this interstellar traveler and the largest planet in our system. When 3I Atlas reaches Jupiter's domain, the immense gravitational pull of that giant world will interact with the object's already unusual motion. The result may alter its trajectory even further as it receives one last powerful boost before leaving the inner solar system forever. At that moment, scientists will be watching carefully, because the data gathered during this encounter may reveal whether the mysterious jet system continues operating as predicted, or whether something even more surprising is waiting to be discovered. And as the clock continues counting down toward that moment, another layer of the mystery begins to emerge. Part 3 will continue directly from this point. Part 3 is approximately equal to 800 words. And as the clock continues counting down toward that moment, another layer of the mystery begins to emerge. Because March 16, 2026 is not simply another date on an astronomical calendar. For researchers studying 3I Atlas, it represents the final moment when this object will pass close enough to our planetary region for detailed observation. After that encounter, the traveler will accelerate outward, crossing the distant boundaries of our solar system, and eventually disappearing into interstellar darkness for thousands of years. To understand why this final encounter matters so much, we need to look again at the physics of the object's approach to Jupiter. On March 16, 3I Atlas will pass approximately 53 million kilometers from the gas giant. In cosmic terms, that distance places it well within the region where Jupiter's enormous gravity dominates local space. With a mass more than 300 times greater than Earth's, Jupiter bends the surrounding space-time fabric in dramatic ways. When fast-moving objects enter this region, they rarely leave unchanged. The gravitational pull of the planet can act like a cosmic slingshot, altering speed and direction through what astronomers call a hyperbolic gravitational assist. Space agencies have used this exact effect many times to accelerate spacecraft toward distant planets. But in this case, the object experiencing the assist is not a spacecraft designed by humans. It is a fragment of material that likely formed around another star billions of years ago. At the same time, several human-built instruments happen to be operating within this region of space. The Juno spacecraft continues its long-running mission around Jupiter, mapping the planet's magnetic field and studying its powerful radiation environment. Although Juno was never designed to chase interstellar objects, its presence raises an intriguing possibility. If the geometry aligns, some of its instruments might capture indirect data from the passing visitor. Meanwhile, another mission has already played an important role in studying the object. During November 2025, the JUICE spacecraft recorded more than 100 detailed images, while several scientific instruments examined the material escaping from 3I Atlas. Those observations included spectrometers capable of identifying complex molecules, ultraviolet detectors analyzing energetic emissions, and particle sensors studying the interaction between solar radiation and the comet's expanding cloud. Yet, for months, scientists could not access that data. Because the spacecraft's communication path to Earth passed behind the Sun, the signals were blocked by intense solar interference. Only toward the end of February 2026 did the delayed transmissions finally reach deep space communication networks on our planet. Researchers are now studying the information carefully, and the full scientific reports are expected to be released around the same time that 3I Atlas completes its Jupiter passage. That timing creates an extraordinary situation. Just as the object begins its permanent departure from our solar system, scientists may finally receive the most detailed chemical analysis ever obtained from an interstellar visitor. Those results could confirm many of the strange properties already hinted at by earlier observations. For example, instruments detected unusually high ratios of carbon dioxide compared with typical solar system comets. Even more puzzling was the presence of nickel vapor, without the iron that usually accompanies it. Such chemical patterns suggest the object formed in an environment with elemental abundances very different from those found in our own planetary neighborhood. The object's trajectory also reinforces the idea that it originated far beyond our solar system. Its orbital eccentricity has been measured at approximately 6.14, an extremely high value compared with previous interstellar visitors. For perspective, the famous object Oumuamua had an eccentricity near 1.2, while Comet Borisov reached about 3.4. 3I Atlas exceeds both of those by a wide margin, moving along a path so strongly hyperbolic that it almost resembles a straight line cutting through the solar system. Because of that speed, no spacecraft currently built could realistically chase it once it departs Jupiter's region. Even today, it is traveling roughly 58 kilometers per second relative to the Sunday. As it gains additional energy from Jupiter's gravity, the object will continue accelerating outward, eventually reaching the distant Oort cloud where temperatures fall close to absolute zero. Before that happens, however, one more piece of the puzzle remains unresolved. Radio telescopes around the world attempted to detect any unusual signals coming from the object during the peak of its activity. Facilities such as the Allen Telescope Array and the Green Bank Observatory publicly reported that they detected no artificial transmissions. Their data strongly suggested that the object was behaving like a natural comet rather than an engineered probe. But there is one observatory whose results have not yet been released. The Parkes Observatory in Australia conducted 3 observation sessions during the period when 3I Atlas was venting large quantities of gas and dust. Those measurements remain unpublished, and the reason for the delay has not been fully explained. In most cases, such delays are simply the result of careful data verification or internal review before releasing findings. Even so, the absence of those results adds another layer of curiosity to an already fascinating story. As the object prepares to leave, scientists are still piecing together the full picture of what it revealed during its brief stay within our system. What we know for certain is this. 3I Atlas has carried material across unimaginable distances, preserving the chemical memory of a distant stellar system for billions of years. For a short moment in cosmic time, that ancient messenger crossed our path, allowing humanity to analyze fragments of matter that formed long before Earth existed. Now the countdown has reached its final stage. Within days, the object will complete its close passage near Jupiter and begin a journey that will carry it far beyond the reach of our telescopes. Once it fades into the dark